3.3 notes, properties of function and the difference quotient, page 3. So, example 5 asks us to use the graph to estimate the average rate of change on the closed interval 1 through 5. And I'm saying closed interval because we have the square brackets on each end, which means it contains the endpoints. So here is one endpoint. It's the 0.15. Here is the other endpoint. It's the 0.57, or roughly-ish, based on what we can read off of the graph. So we're going to go f of 5 minus f of 1 over 5 minus 1, so y sub 2 minus y sub 1 over x sub 2 minus x sub 1. F of 5 is 7, f of 1 is 5. 5 minus 1 is 4. We get 2 over 4, which reduces to 1/2. Always reduce a fraction if you can. Again, no reason to convert to a decimal and make more work for yourself. That might mean you get it wrong. Second part of that asks if the average rate of change for this function will always be positive, and it's going to depend on the 2 points we pick. So I could pick the interval from 1 to 3, and I'm going from the point 15231. If I connect those 2 points with a secant line, notice that the slope on that is going to be negative. So we can simply state that, no, the closed interval from 1 to 3 has a negative slope. You got to be specific. You don't necessarily have to figure it out. To justify drawing that secant in there and showing that it has a negative slope would be enough. We are going to use graphs to determine where a function is increasing, decreasing, or constant, and also use a graph to locate local maxima and minimum. So we're going to start by just kind of going with the gut and what we know. So the zeros are let's put this in here. Let's make sure we can read it. The zeros are the x values where y equals 0. So I got a 0 right, let's change the color so that it stands out a little more. Right here at -4 when x is -4, y is 0. I got a 0 right here at -1 when x is -1, y is 0. And then a 0 right here at 3 when x is 3, y is 0. That is related to the x-intercepts. The x-intercepts are where our graph crosses the x-axis. These are intercepts. They are the point on a graph. They need to be written as an ordered pair. Y-intercept. Of course, where we intercept the y-axis, this one here is shown for you. Our y-intercept is the point 0, -12. A relative minimum. So a relative minimum, it's also going to be called a local minimum, is just going to be lower than anything close to it. And so I'm going to write that here so you've got that, lower than anything close to it. That's going to be this point right here, 1.4, -20.7. When we talk about the maximum and the minimum, we are talking about the output value. So the minimum is the -20.7. It occurs at 1.4. Okay. So the minimum or maximum value itself is the y, it's the output. Sometimes it's important to know where it happens. Actually, let's fix this, x equals 1.4. The relative maximum then is going to be higher than anything close to it. So here's our relative max. Also could be called a local max or local maximum. 12.6 at x equals negative 2.7. Domain is the set of all possible x values. So here, even though we don't have arrows on the end of this, that's a function of the graph. We also don't have solid points showing that it ends, so we're going to assume we have arrows. Our domain here is going to be all real numbers. And our range, even though we have a max and a min, notice that off here to the right, it shoots up to positive infinity. Off to the left, it shoots to negative infinity. So our range here is also negative infinity to infinity. So H, where does it look like the graph is increasing? Again, we're going to go with the gut. A graph is increasing if, as we read from left to right, it's going up. So our y values are getting bigger. So here our graph is increasing. See if we can color coordinate. So the graph is increasing from negative infinity to negative 2.7. We look at the y values to determine what is happening. We define where that's happening in terms of the x values. So also over here on the far right, from 1.4 to infinity, our graph is increasing. Decreasing, right down here in the middle from negative 2.7 to a positive 1.4. Our graph is going down as we read from left to right. So decreasing here from negative 2.7 to positive 1.4. Notice the parentheses on the end. We could not use an endpoint and have it decreasing to one side and increasing to the other. So when we are talking about increasing and decreasing, the endpoints are not included. So the endpoints are not included for increasing and decreasing.